Um, Today we're doing an introduction course to Python. I call this the pre-Python course because today we're going to go over terminology, tactics, things that you should know in Python in order to actually take the course. If you know these things, I found you can take the course all by yourself, even self-teach. You don't even need a teacher once you understand these concepts. And we're very, very fortunate to have with us Cynthia Sheffield from the National Library of Medicine. Cindy's face is on her video's on, so you can say hi. She is one of the most phenomenal teachers I've ever seen in being able to relay these concepts. So when we move to the section where she actually teaches Python, you will be in very good hands. She has done this for us before with remarkable success. She is at the National Library of Medicine, and she does many things with health disparities and language and terminologies. So I always get excited listening to her because I always learn something, even when I've seen it before. We're going to start, though, with an overview because some of you are new to the Think-a-Thons. This is a platform called ScHARe. It's called the Science Collaborative for Health Disparities and Artificial Intelligence Bias Reduction. This was created to meet the needs of cloud computing, especially for population science, health disparities, and social determinants of health. And what we're going to cover today is what is ScHARe, why Python, and go through some Python tutorials if we have time after Cynthia's presentation. And what I mean by that is on the ScHARe platform, we have notebooks of Python where you can cut and paste and do your analyses even though you don't know Python. And Luca will go over some of those things with you. I'm going to turn it over to Mark right now. We have a few polls that we would like you to participate in. Mark, if you want to take it over and do Slido. So as I said, please log in to Slido. These polls are very important to us. We pay attention to them and it changes how we do things. So we appreciate your input. So Mark.
Absolutely. So as Dr. Duran mentioned, we're going to be using Slido for audience interaction today. We'll have several polls throughout the webinar. So we start with an experience poll. There will be a few questions. You can join by going to slido.com and entering code Python. You may also use the QR code that you see on the screen, or you can use the link that we've put into the chat. And I'll ask Catherine to put it in one more time because I know there've been quite a few chat messages. So just to make it convenient for everyone, we'll put it in one more time. But you can join us through any browser or in the Slido app on your phone or tablet using the code Python. And so you'll have a few questions to respond to help us understand your experience level with a few different things. The first of which is Python, as you see on the screen here. And it looks like about 2/3 of the participants today have no experience with Python. So I suppose you're all in the right place then. So Dr. Duran, let me know when you want me to move to the next one.
Next one.
Okay. Experience with R.
The reason that, yes, R can be used in AI and many of the things that can be done, but Python is sort of the classic language of AI, and that's why we're really trying to push people to learn it. And for those of you who are more senior investigators like me, I don't necessarily need to know how to do everything in coding Python, but I need to understand the concept. So when they bring me an algorithm or they bring me code, I at least have an understanding that I can then put my insights into. So I think it's very important for even senior investigators to become familiar with it. Even if you know are, I would suggest that you still focus on Python. Next. So this is experience with cloud computing, which is good because you're in the right place also. And this is why we're going to introduce you to ScHARe. Next. And of course, not many people will have involvement with Terra. Terra is our interface, and I'll explain this to you in a few minutes, to the ScHARe platform. Next. And you're our perfect audience, that you have some health disparities research, and we always like the none category because I know that we're going to sway you into this field of research. Next. Same thing with outcomes research. Next. And one of the reasons that I think it's important even for senior investigators to learn Python is because of this bias mitigation. We have to be able to understand it enough to know how to mitigate biases. Next.
That's actually our last experience poll. Do you want to go to the interest poll next?
Yeah, let's do the entrance poll.
All right. So next question is going to be about your interests. So this is a check all that apply. Please let us know which of the options are interesting to you. All of them, okay. Excellent. While people are responding, just a reminder that all of the polls today will be in Slido and all available from the same link, slido.com, enter code Python, or use the QR code. So no matter how you got there, this is the same place where you're going to go to answer all the poll questions today.
I'm really excited to see the learning AI tools and cloud computing, because this is really where the field of research is going, because it can do so much more than what you can do on a laptop. So I'm very excited that you're here and wanting to learn this, because we're helping raise the bar. Okay, is that it?
That's the last one for now, so feel free to take it back over.
Yeah, I'll take it back. Can you see my screen? Yeah.
Yes, we do.
Okay. So what is ScHARe? ScHARe is a cloud-based platform. We have a unique niche at NIH because we focus really on population or social sciences, the social determinants of health. And that research actually is what feeds into health disparities, health outcome, and health care delivery types of research. Because we are the National Institute of Minority Health and Health Disparities, and we represent vulnerable populations, we of course are very interested in bias mitigation strategies. I am an advocate that biases will always exist just because of the nature of data. We can't do everything, but we can be very mindful in how we do ethical AI. And so part of the whole purpose of ScHARe is to increase the participation of women and underrepresented populations in data science. We want to create a paradigm shift in how we do research in these areas so that we know how to use big data. Genetics is way ahead of us in how they do this, and the social sciences need to catch up because there's so much more information that we can learn when we can put more variables and the data is bigger. We have, of course, focus always on bias mitigation, but more important, especially when we do the research Think-a-Thons, which I'll talk about in a second, we really emphasize ethical AI. Because if we all learn ethical AI, then we don't have to worry about harm being done to population groups. And the other one very important aspect of this is that many minority serving institutions, low resource or community colleges can't afford a cloud like this in order to teach data science. So this tool is actually available to any academic institution, organization that wants to teach data science and use the data sets and the platforms that we have. We use TERA as a interface. So it's a Google background. That's why you have to have a Google email, like a Gmail account. For those of you like us at NIH is also linked to Google, so we can just use our work email. But for some of you, you may have to create a Gmail account if you haven't already done so in order to access. TERA provides an interface, so it's that part that helps you to navigate through the system. One of the other reasons we chose TERA as an interface is because there are other major cloud platforms at NIH, like All of Us, Anvil, and Biodata Catalyst. We all use TERA. Because we all use TERA, it makes it easier for us to be able to go across platforms. So for instance, if you wanted to do an epigenetic study, you could use ScHARe and Anvil as data from both of those platforms. There are several components to the ScHARe system. One of them is we have data sets. We're launching a repository in September. We have all the computational tools for AI types of analyses on the web page. We try to do low cost, low resource tools to make it affordable, because part of the reason people don't do AI is they say it's too expensive. Well, it's not. And you just have to know how to approach it to make it not. And of course, we have many of the tools to evaluate and look at bias mitigation. As you can see on the right-hand side, we have a web page that's at the NIMHD website. We also have federated data and a repository full of data. TERA provides a secure workspace. This is important because one of the reasons that so many people don't do cloud computing is because they think, oh, my stuff will get hacked or violated or stolen, but that's not true. These secure workspaces are as secure as your laptop. You have a choice to let people in to collaborate with you. You have a choice to keep it totally private, so it's only for you. You can also set this up to be available to a whole classroom of people. So the secure workspace, no one else can get in without your permission. We also have, as you can see, these notebooks consist of many codes. So it's cut and paste analysis. It allows you to be able to just go in and cut and paste a code so you don't have to write it out yourself. And if we have time, Luca is going to go over some of those for you and show you how to do that. And we have over 260 data sets into the ScHARe platform now. You can see what data is there by going to the ScHARe webpage, or in many of you are already logged on, I hope. And you can just open up where the data sets are to know what the data sets are included. They are organized by the social determinants of health, the 5 main categories, plus an addition of behavior and disease and disorders. So this is what it looks like on the screenshot once you're there. As I said, we have, it's actually 260 now, federated data sets, and we're releasing a repository in September. This is important for all of you who are NIH grantees. This will comply with your mandate for data sharing and data management. The focus of this repository, though, is the social sciences, not genetics. Of course, you can put it on here, but there's no other repository at NIH that focuses on the social sciences, the social determinants of health. So this will be the place, the repository, to do that. We're using a common data element approach to deposit the data. What this will allow us to do is to create an interoperability, a harmonization across data sets that you don't have in the other ecosystems, in the other repositories. As I said, they're organized by the social determinants of health plus health behaviors and disease conditions. And it also has data over time. So it can go back, I think I had them limited to 10 years, historical data. And so you can actually do studies of longitudinal types. The social determinants of health, as many of you know, it's where we work, live, and play. It's all the data that is non-medical, but impacts our health. It's estimated to be anywhere from 35 to 55% of our health is impacted by social determinants of health. So education is one, healthcare access, neighborhood and built environments, social and community context, economic, health behaviors, disease and conditions. Oh, I think this is an important point. Your demographics are not social determinants of health. Demographics are things like age, race, ethnicity, gender. The isms associated with those things are social determinants of health. This is an example of a few of the data sets that we have. Some of the more popular ones, like American Community Survey, Area Deprivation Index. There are so many more, so please look at them. There are 2 different types of hosting processes on ScHARe. One is that ScHARe pays for the hosting of the data, and the other is Google. And so this is just how you access the Google data. I always make fun of this because we're on a laptop, most of you, so you can scan that barcode and it'll give you a list of the data sets in PDF, but you can't scan it on a laptop. We use common data elements, and I'm always want to introduce these because these are the wave of the future. The reason that they're the wave of the future is because we have to get out of this mindset that our data is only ours. In this world today, data belongs to everybody. And the reason you have to post it and data management and data sharing is because other people want access to the data. Well, in order to get that, I'm sure all of you who have ever cleaned a data set knows and tried to harmonize or merge 2 data sets, what a nightmare that is. When we use common data elements, it helps that process. It makes it easier to be interoperable. So our approach to this repository is to have common data elements and everybody's project, so you can see how easy it will be to merge your data versus somebody who didn't use them. The core common data elements that we are focused on are these. The top 20 are reported by the individual at the individual level, but we also have 2 project level ones, the NIH framework and the health disparities outcomes. Those are done at a project level. This is the reason why this is so important, is because when we use common data elements, it makes metadata easier to ascertain across studies, and it makes it easier for the linkages to occur across platforms. In the new repository, this is what it's going to look like. You can upload your data and create a new collection. A new collection is your data. It is configured so that the CDEs that I showed you in the last couple of pages actually can map to the questions in your data and enable the, so you can see the percentage of CDEs that are in line with ScHARe. And when it shows that alignment, this is on the front page of your collection, it'll show, like in this case, 7 out of 22 were represented. Sometimes you'll see 20 out of 22. Of course, then you want to pick a data set that has the 20 out of 22 because you're going to have better harmonization. We created this so that it's easy to use. It's a drag and drop. So you don't have to do a coding to upload your data. You just drag and drop. We also have created a tool that what we call data aggregation. So you can actually put together different data sets into an aggregated data set. We asked always that you save that so that on the ScHARe platform, because when you save it, then the next person doesn't have to aggregate those 2 data sets. The last piece I'm going to cover are the ScHARe Think-a-Thons. We do these monthly Think-a-Thons. Some are tutorial like today, and some of them focus on research. And we have some research ones going on now, and we will do some research ones and probably launch another set in a couple of months. These Think-a-Thons are really multi-generational career and discipline levels so that everyone learns from each other. Data scientists learn from health disparities researchers. Health disparity researchers can learn from coders and analysts. We try to also teach things like Python. We go over how to use the Terra platform and to use ScHARe. We go over what data science is. We go over computational skills. There's all kinds of tutorials that we do. And the research Think-a-Thons, it gives you hands-on experience using big data, but taking a very ethical AI approach. These are the ones that we've done so far. You can find them on our webpage. I think Mark put them in the link in the chat. And so you can go back and watch these videos or get the slides. When we conduct these Think-a-Thons and what we mean by ethical AI, as I said to you before, I don't think biases can ever be gotten rid of, but you can be transparent and know the limitations of the data. And we do that by really advocating for data dictionaries, house sheets, model cards. And we're actually creating, thanks to one of our staff people, Elif, almost like a food label that you see like on your pasta box or your milk carton, so that we can have a clear schematic of what the data is, because transparency is important. We also are in partnership with Aim Ahead, which is another cloud project really focused on raising and upskilling the underrepresented in data science. We start you off here, and then we try to launch you into Aim Ahead, which has fellowships and other training and actually grants that you can apply for and do AI types of projects. This is how you can scan Aim Ahead if you've never heard of them before and connect with them. You can also Google Aim Ahead. I'm going to turn this over to Luca now and stop sharing, because he's going to take you through how to register, how to get on, and then he'll move you right into Cynthia's presentation.
Thank you so much, Debbie. I'm opening my presentation. Okay, so can everyone see my screen? Debbie, can you see?
We see it.
Okay,
Yes.
perfect. Thank you so much. So I'm going to guide you through some steps needed to work on our tutorials today. So first of all, as you know, you have been registered for ScHARe, and we have also added you to a free temporary billing project that will allow you to run the event materials today with Cindy and Elif and me, your instructors. You will be active on this billing project for like the duration of the event today. And then if you want to access work in progress after today, then you will need to set up your own billing. We do provide instructions on our ScHARe Think-a-Thon website. There are instructions provided in the past events. You can refer to those. Or I'm also happy to help you. You can contact me and I'll help you do that. And of course, you're free to opt out if you want. You can always email us at share@mail.nih.gov. So that said, I would invite all of you to copy and paste this address in your browser. So actually, Kevin or Mark, could you please do that for me? The one you see on screen. Thank you so much. And then if you have already created a Terra account and are already logged in, I know that some of you were trying to log in earlier. So if you are logged in, you just see this or something similar. If you are not logged in, or if you have not created a Terra account, you will see this homepage inviting you to create an account and sign in. So the next step from here is going to be to create a Terra account. So I'm going to help you with that. So again, if everyone can copy and paste that address in your browsers. The next step is to click on the login button that you can see there. It's a blue login button.
Excuse me, Luca, for
Yes.
those of you guys, if Elif just registered you, there might be a little bit of a delay. So if you just got signed up like within the last 15 or 20 minutes, there could be a little bit of a delay. So keep trying as it catches up, the system catches up. And for those of you after Luca is done, I'm going to ask those of you who cannot log in and you've provided your email, I'm going to ask you to raise your hand. The contractor will move you into a breakout room and Elif will help you get registered. Okay? Or you can just observe. Like I said, everything will be posted. There's not It's not like you have to. Catherine?
Thank you, Deb. So I'm going to go on, and we're going to repeat this actually 2 times. We'll give you plenty of time to do all the steps. So on the home page, click on the login button. And what you will see is this screen inviting you to sign in with Google. So please click on the sign in with Google button. And we are going to use the Gmail address that you provided us with to log you in. So once you click on sign in with Google, you'll be brought to this screen, inviting you to input your email address. So again, that needs to be the Gmail address that you provided us with. So you just have to type it there. And when you're done, you can click on next, the next blue button at the bottom. And again, I'm going to repeat this once more. Then the next step is to input your password, which is the password associated with your Gmail account that you just used. And once you do that, you click on next again. And you'll see a page where you'll be asked to input your first name and your last name and a contact email for notifications, which can be different from the Gmail address you just used, or it can be the same as you prefer. So input your first name, your last name, and then click on register. And the next step is going to be accepting the terms of service. So you see a window like this, just scroll down to the bottom and click on accept, the blue button at the bottom. And once you do that, you will see this welcome page saying welcome to ScHARe Community Workbench. And at that point, you'll be able to see those notebooks if you use that address again. We're going to get there. I'm going to repeat these steps first to make sure that everyone is up to speed. So again, you can use this address, paste it in your browser. And if you don't have a ScHARe account or are not logged in, you will see this screen. So on this screen, press on the blue login button. And then click on sign in with Google. Then input the Gmail address you just gave us. And then click on next. Input your password, the one associated with your Gmail account, of course. And then click on next. On this registration form, input your first name, your last name, and a contact email. And click on register. Then on the next screen, accept the terms of service. So scroll down the page and click on accept. And you should be done. You should see something like this, a page saying, welcome to ScHARe. So has everyone gotten here?
Okay, if you don't have it and you want to, raise your hand, keep it raised. Our contractor is going to put you in a breakout room, and Elif is going to go to the breakout room and help you get registered.
Right.
So keep your hand up if you want in.
This is what Debbie was actually mentioning before, you might see an error message like this, which is normal because like Google needs to sync permissions, for the workspace. So this message should go away in a few minutes. If you're experiencing this, just refresh the page in a little while and it will go away. And actually, I'm going to show you live what you should see. It's going to be even easier. I had slides, but I want to show you live. So you can see here what you should be able to see using that link. So this is the workspace that we're going to use for our tutorials today. And you can see that in the analysis section, which is the section the link already points you to. So you should get to this page. And you can see that we created several copies of the tutorial notebook. So there are, so many. So just pick your initial based on your last name. So if your last name starts with an A, click on this notebook here. If it starts with a B, on this one, etc. And click on that.
Okay, let me clarify what he means. Go back to that code,
Sure.
please, Luna. So if you look at where it says Python code basic copy, and then you'll see an A, B, C, D, E, F, G, H, right?
Yeah, it
And
goes
then
on.
the IPNB. But what he's saying to you, because if everybody's in the same folder, it's just too much. So we created multiple folders. It's exactly the same. So don't think your A is going to be different than G. It's exactly the same. So, but what we're doing it this way so we don't get a jam, a log, like a. So what he's saying to you is look on these copies and pick according to your last name. So my last name is Duran, so I would go to the one that says D. And Luca would go to the one that says C. And Cynthia would go all the way down to the one that says S. Okay?
Exactly.
All right.
Thank you, Deb.
Click.
So I'm going to click on the one starting with C. And the next step from here would be to click on Open on this button here saying Open.
It's going to be the same in every file, so it doesn't matter. This is what it would look like. And now you're going to click Open.
Perfect. And then this window shows up. And here you're asked to set up the virtual machine that is going to run your notebook, meaning it's like a virtual computer that actually runs all the computations for you. And you don't need to worry about anything here. So you can leave the default values as they are. So all you have to do is to scroll down here until you get at the end, and there is this Create button. And you have to click on that. So leave all the default values here and click on Create. So I'm going to do that again. So once you get here to the analysis page, pick the right notebook based on your the initial of your last name. Click on it. Then click on Open. Don't worry about all these settings. Just scroll down to the bottom and click on Create.
Could you just repeat which notebook to open, or which?
Yeah, sure. Of course.
Whatever your last name is. So you're a P. So notice
what's your last name?
P-E-N. So you scroll all the way down.
Exactly. And you would have to open
and
this
find
one.
P.
Yeah. So
And actually, It doesn't matter what you click on.
Exactly.
Click anything. If you
Don't
can't
worry
find
about
key,
it.
click on something.
Don't worry
They're
about
all
it.
the
It doesn't
same.
really matter. Yeah,
They're all the same.
just pick one.
We did this so that it's not jammed up. So just
Yeah.
pick one.
Sometimes when we get like, many users, it becomes difficult. So now it takes some time to create your cloud environment. And what is important, once this is done and you're ready to go, you're going to run this notebook in playground mode. So you see that now a playground mode button has appeared next to the open button. So when the cloud environment is ready, you'll have to click on this button here, playground mode. And we're done. That's all you need to do.
We'll come back to that part when we're about ready to use it, and we can start with Cynthia now.
Of course.
As many of yours are still creating your cloud environment, Cynthia can start the intro, and we'll come back to this page, and Luca will remind you then to hit playground mode. Okay, and because at first Cynthia is just going to explain some things to you, and I'll give you time to get the cloud computing environment revved up.
Perfect. Thank you so much. I think I'll turn it over to Cindy right now. And Cindy, it's all yours.
Okay, thank you, Luca. Thank you very
Thank
much. It's great to be here. Let me just go ahead and share my screen. Make sure I'm set and that everyone can see my screen okay. All right, can you see my screen okay?
Yes, we can.
Okay, great. So what I'm going to do is just kind of go through some slides and kind of talk about Python and generalities, as well as some IDEs that you could use if you're not using Terra. Today we're going to use Terra. I'm just tossing this information in as extra information that you can use if you're not going to be using the Terra platform, on how you can try and learn your Python skills independently. So with that said, let's go ahead and get started. Again, I'm delighted to be here. I think this is such a great project. I think it's so incredibly good that, ScHARe is teaching all of you how to bring data into a cloud platform environment, and that you can do things like Dr. Duran said earlier, where you can perhaps maybe merge data and combine data from another platform like Anvil or All of Us. So I think that that's extremely exciting for all of us as scientists, because we can make such great use out of the data that's provided to us or available to us on all of these platforms. And of course, those common data elements are key to that. So Python is a great tool to use, plan and capture, organize, analyze, and disseminate all of your scientific research. Experiments can be documented using code. Not only do they help you improve rigor and transparency to what you're doing in your science experiments, but they also help you make changes to your documentation or share your information more effectively. If you can copy and paste, 90% of what you've already done, and just tweak it a little bit for a new variable, that's so much more efficient than trying to recreate documentation through MS platforms and that type of thing. So code's extremely valuable that way. This session is really going to provide you with a high-level overview of the basics of Python code. We're going to just cover foundational components of coding so that you have an understanding of what you need to learn. As Deborah said earlier, you want to be able to understand code so you can converse with other scientists. And this will also teach you how you can approach learning programming language on your own, and what you'll need to know when on Python code. There are pieces where you're like, I need to know that piece. Go learn that piece, and then you've mastered that, and then you can move on to the next thing. It is designed for individuals who are interested in learning Python, but not exactly sure how to approach going going about learning Python. And again, these slides and code are available to you, especially now that you have access to Terra. So one, I'd like to start with just a quick poll. If we could go ahead and run that other poll, just to gauge your level of knowledge. And while you take that poll, let's see, I'm sharing my screen, so I'm not sure if you can view the Slido poll with me not sharing. I didn't think about that.
I can
Go
take
ahead.
over and share for just a second if you want.
Yeah, go ahead. Please do
Okay.
that, Mark. Thank you.
Will do.
So I'll stop share so you can share. And while he's launching that poll and you're taking the poll, I'll just kind of review some of the things that we'll learn during this session. So one, we want to understand how Python can help us, one, document the experiment process, and two, improve your data science skills. And we also want to recognize various components of code within Python, and then recognize the 4 different IDEs that can be used to write Python code as you're learning code. So great, we do have some people who have Python experience and some who know other coding languages. This is similar to the earlier poll. So I saw many of you know R. If you learned R, you can learn Python. I, dabbled in R for a while, and then there was a big need. I saw the growing need for Python. So I sat down and really learned the basics of Python simply to really provide this type of instruction. And for those of you who have said, I looked at Python code but don't fully understand it, I certainly relate to that. It took me 5 attempts at learning R before I actually started to absorb R. And for the almost 40% that says, I want to learn Python, but my brain hurts. Yes, indeed. All code makes your brain hurt, but it feels so good once you've mastered some concepts. So there's your motivation to learn. So with that, I'll go back and share again. I'll take over the share and share the slides again. So I just reviewed verbally these learning objectives. Oops. Make sure I'm actually sharing that screen. It's always that second share button that is most helpful. All right, so why do you want to learn Python?
We don't see your slides. We see you've got the Python code basics and then Word document.
Oh, thank you. Let me stop sharing and reshare again. Thank you very much for that.
Of course.
My cheat notes. That's what you saw. Thank you. Okay, so why would you want to learn Python? First of all, can you see the screen okay?
Yes, we can do it now.
Okay, great. Thank you. So why would you want to learn Python? It is a scripting language that can help you structure, document, analyze, and formulate and archive your research data effectively. So ultimately, it will save you time. It's an object-oriented open source programming language that's freely available, and it runs on most operating systems. It's powerful for analyzing and visualizing your data, and we'll take a look at that later on, and for writing text or markdown to support your data. And markdown.
It's not moving forward if you're moving slides.
Oh, okay. It should just be why you learn Python.
Oh, okay.
For right now. Yep. Perfect. Thanks. Python can help you document your experiments in a way that you can reuse sections of in a modular fashion. It also helps you expedite documentation as you prepare or present your research. So again, Python's relatively user-friendly. It's easy to read, it's easy to learn, and it facilitates effective data management, data analysis, and processes documentation. And in short, it'll enable you to create your document and document your routine science processes, execute those processes, and then perform analysis and visualizations effectively. And we'll take a look at that on your next slide. So let's start with the how and why Python will help you with your research. All scientific theory is data-driven, and so many investigators use applications like MATLAB. Python supports automation of those routine tasks that you create in science, and especially when adjusting variables within that scientific method. It also supports machine learning and deep learning to look for patterns and correlations. Vinay Rahu from IBM said it best when he wrote, "The optimal approach to solving a set of problems may vary, and thus we need different tools for each approach. Python code serves as a wonderful toolkit with which to integrate all the problem-solving tools into one container. Python gives scientists a powerful way to wrap special purpose tools and make them easily accessible from a common application layer." It really allows you a little more flexibility than other applications might allow you to when you're documenting. With Python, you can complete the work for your full research cycle within a single Python script. You can write your problem statement, compose your research methods, collect your data, generate those results, and then visualize their significance, and then write up an analysis and discussion of your findings and your conclusions, and generate your references. And there you've completed a paper or a presentation. So now we're going to take a very high level 1,000-foot view of Python code. And again, our objective here is to get a flavor of the concepts that you'll eventually need to understand. It's not to actually consume these concepts during the session. The goal is to pique your curiosity and show you what can be done and how this will make data analysis and processing aspects of your research more efficient and easier to document and share. The goal is not to overwhelm you with weeks worth of information in a single hour. It's just to give you a flavor to let you know how you can spend future hours. So here are some of the concepts you'll want to know: syntax, variables, functions, data types, conditionals, and libraries. So let's start taking a look. Syntax refers to the tools to the rules in writing Python code. There are lots and lots of rules in Python. Syntax rules will stump every coder at some point, but as you learn these rules, errors are less likely to occur. There are rules for creating identifier names. If you think of an identifier as the nouns that you need to define, then identifiers can be assigned to variables like x plus y. And then there are functions, which are short bits of code that perform a task. And then beyond functions, there are classes that behave as a template that creates an object. It allows us to bundle data and functionality together. For instance, if you think about building a house and you need blueprints to define the function and the source materials you need to build that house, that's a class. And then class names need to be in uppercase in Python, while other identifiers can be in lowercase. So again, these are all syntax rules you'll need to learn eventually. Punctuation is important in Python, whether it's a colon or a quotation or closing a paren or perhaps a bracket or a squiggly bracket, all shown here on the slide. Once you understand the what and the why and the where, finding these errors will become easier, and then creating them becomes less frequent. Loops and if statements must have logical indentations, 4 spaces or a tab, or your code won't run. Loops are used for iterating over a sequence, and if statements are used to determine if a criteria has been met before moving on to that next condition. You'll learn to comment code, which is very helpful to others using your code, including your future self. And comments require either using triple quotes or the pound sign. So there are reserved words which perform very specific tasks within Python code. It's simply best to avoid using reserved words as identifiers. You cannot use these terms without risking finding errors or generating errors in your code. Excuse me. Variables are containers for storing data values. Values can be either a single item, like a number or a character string, or an equation, or maybe even a range of numbers. And a variable could be a tuple, a list, a dictionary, or a data frame. And I'll talk about those, what all of those things are in a few moments. A variable is created as soon as you assign a value to it. And a variable can be either a single letter or it could be a meaningful phrase. It's completely up to you as a coder. Functions are blocks of code that perform a specific task or analysis or maybe create a parameter. Functions return some result, and this additional information can be passed into other functions as an argument. Functions always start with DEF and then list the function and the parameter being called by the function. In this example, Greek is the name of a function, and it's calling the parameter variable named. The parameter variable named will equal whatever character string is defined by greet noted below the function. The function will print hello plus the value of named, and then we'll end the sentence with an exclamation mark. So this code will produce the statement, hello, new Python coders. And then in a couple of months, I could change the value of the parameter named to equal the character string experienced Python coders. The URL will take you to a list of a lot of functions already built within Python. So be sure to view that after class. That'll save you lots of time when coding. So here are two of the main data types used within Python, tuples and lists. And these are the two that we'll play with in Terra. So tuples are ordered elements, that cannot change over time. They're denoted in Python by being placed within parentheses. One example is found in arithmetic, like the order of operations. Remember, please excuse my dear Aunt Sally, at least if they're still teaching that. And then lists are created by placing a set or ordered values inside brackets. Lists are the most versatile data type within Python, so order does not necessarily matter in lists. And here are examples of three lists: names, cities, and items. Dictionaries are stored items in key valued pairs. They're changeable and they don't allow duplicates. They're often stored data values like a map. Note that names is paired with Annie and items is paired with apples. And then sets are mutable, not a fixed size. They're unordered, so the order doesn't matter. And the elements are unique, so you can't repeat an item within a set. And note the difference between the sets shown here and the list from the previous slide where elements could repeat. Conditionals can be either loops or if statements that iterate through a sequence to determine if the element in the sequence meets a condition. And if so, some process happens depending upon the outcome of the condition. Loops and if statements are really a key part of Python coding. Loops allow you to evaluate a range of data points against parameters, and we'll look at that in Terra. And then loops will make an argument. An argument is a variable that's been assigned to either a tuple or a list or a dictionary and runs through a sequence until either the end of that argument or until it reaches a condition where it's designed to stop. If statements will check for a condition and then process that information as it's directed. And the code, this slide shows simple examples of each conditional. And again, the point of the information is just to make you aware that these things exist, but not necessarily to absorb all of this and understand it completely. It's impossible to teach Python in a single hour. I just want to keep reminding you that this is just a high-level overview. Data frames are really the most frequently used data structure in Python. You can think of a data frame as any table that you might use, whether it be an Excel file, a .csv file, or perhaps from SQL Server. But these are the most frequent structures you'll be working with. To do that in Python, you need to use a Python library called pandas. And Pandas is a fast, powerful, flexible, and easy to use open source data analysis and manipulation tool built on top of Python programming. You'll read this tool will read in your .csv or data frame into your code, and it works along with other libraries to perform statistical analysis and visualizations. To bring this library into your code, you would simply type in a coding example as shown on the slide, import pandas as PD, and just using that as PD allows you to perform some shorthand on the code, which really saves you a lot of time eventually. Here also on the slide, we create an identifier or variable called df alpha song, and that is going to be the variable that brings our table into our code. And again, don't get too worried about the details today. The idea is to capture those concepts. The process is you assign a data frame to a variable so that you can read that data into your code, and then you can perform analysis on the data within that data frame. We'll look at specific examples when we get to Terra. There are many Python libraries that can be found at pypy.org, and here are just a few examples. Pandas, NumPy, which I know has been mentioned earlier. Matplotlib is really powerful for visualizations, and Seaborn. We'll be using all of these later on when we get into Terra. Okay, so that concludes our very brief tour of Python coding. We'll look at more specific examples of code when we move over to Terra and then run code snippets within that environment. And you'll have a chance to run code there on your own computer. However, before we do that, I do want to check and see if there are any questions in the chat. And if so, or if you have questions, please do put them in the chat and we'll try to answer a few of those. Now I'm going to go ahead and turn off my camera just real quick.
Are there any questions that somebody wants to ask while they're transitioning to live? If you do, turn on your cameras and just ask. How long does it take to learn Python?
Well, you know, it really depends upon your motivation, I would say. You know, if you're really bound and determined, I would say I spent a serious focus for 6 to 8 weeks, and that got me over the initial hump to learn what I know now. And so I think you could get a good baseline of coding in 6 to 8 weeks.
There's also very many free courses that you can take online. Even Harvard offers free courses. And I think Luca will give you a list of those at the end. So you can do them also on your own. Cynthia, there was a question on to define what a tuple is.
Absolutely. It's an unordered pair. Here, let me go back to that slide real quick.
They're not going to see it because you took it off.
Oh, we can see it.
So just say what it is.
Sure. So again, it's one sec. They're really, I wanted to make sure I got to the very specific definition. They're ordered elements that can't change over time. So if you think of the math equation, my dear Aunt Sally, where you have to have that very specific order of operations, parentheses, what is it? Parentheses, exponents, multiplication, division, addition, subtraction. So you can't change that order. So tuples are ordered elements that just simply don't change. The other thing that denotes elements are they use parentheses, whereas lists use square brackets. Okay. Okay, so with that, let me move on to just kind of our high-level overview of IDEs. And again, I'm just going to kind of breeze through this quickly because we're using Terra today. We're not using any of these IDEs. But if you wanted to use an IDE, Colab, Google Colab really is an easy platform to use.
Yeah, they want to know what an IDE is. So you
Sure,
can
sure.
spell it out.
Absolutely. So IDEs are integrated development environments. And again, they're commonly referred to as IDEs, and these are platforms that that are helpful while learning and writing Python code. They help manage active code within the console, as well as project files and other data files. And they track active variables and offer features such as autocomplete to complete a variable or function name. And they also offer debugging tools, which are extremely valuable when you're writing code. Google Colab even offers an AI tool now, which will finish writing your code statement for you. It's pretty powerful. And I've used it to debug some of my code. So it's something to consider. This is a list of freely available IDEs for Python coding. But again, today we're using Terra. Beyond Terra, these 4 free IDEs can help you process your code. So if you created a code file in Terra and downloaded it, you could upload it in one of these tools. And then assuming that you also move the associated data files that run with that file, or that you have the capacity to do that. For instance, if you had patient identifiable data or proprietary data, you certainly would not want to move that into Google Colab, because Google Colab is open source and it's not secure. Remember, Dr. Duran was talking earlier about Terra being a secure environment. Google Colab is not that. So anyway, I just wanted to point out that you could do that. And again, Google Colab is free and easy to use. It's really a nice platform for learning Python. It works very well with Jupyter Notebooks. It allows you to write script files and data files that can be stored on either Google Drive or GitHub. And the URL shown here will take you to Google Colab so that you can get started quickly without having to install anything on your own system. But again, you don't want to use PII or proprietary data on these systems. This slide talks about Anaconda, and Anaconda is software that you can download. It does take a lot of memory, but it is a platform. It stores lots of other coding platforms, like RStudio is in there as well. I've grayed out all of the other options just so we can focus on the 3: Jupyter Notebook, Spyder, and Jupyter Lab. Anaconda is, again, an open source suite of tools, of software tools, and it takes a fair amount of memory, but it again offers a nice collection of tools. To use Anaconda in your computer, you will need to install it. If you're using an institutional computer, you might need administrator privileges to help you install that software. And PyCharm is in Anaconda, PyCharm has also become a very popular coding tool. I've never used it, but I understand it makes coding much easier, but it is fee structured. So you might want to bear that in mind as you're learning. The Spyder IDE is a lot like RStudio for those of you who have experience in coding in R and using RStudio. To launch Spyder from Anaconda, you just simply click the launch button, and then you can go to either file open or file create and begin your coding there. The other platforms are equally as easy. Jupyter Laboratory, again, you just launch it and then either create a file or open a file. What's nice about Jupyter Laboratory is it allows you to have multiple files open at one time. So if you have multiple code scripts you want open at a single time, or perhaps a coding script as well as a data file that you can toggle to the background and look at the raw data. That's what I find is the most appealing feature of Jupyter Laboratory. I'm sorry, this is the slide for Jupyter Laboratory. I've got my slides and my notes mixed up. I'm so sorry. This is a view of Jupyter Laboratory. You can see that the tabs are open here. Let me just go back here very quickly. Jupyter Notebook allows you to open the platform, and you would simply find a file and then launch your code from there. And then Spider, again, is a lot like R and RStudio, where you have your console view. You can view your results here, your code here, and then your elements would show here in variable and plots. But again, this is just a quick high-level overview so that you have an idea of what these platforms are and where you can find them, what you might find in them. Here's where I'm going to stop using the slides, but I want to point out that each of these IDEs has attributes that are pretty similar. I encourage you to kind of take this list and explore those different IDEs if you're interested in using them. This might help you become a little familiar with them and decide which platforms would work best for you. So with that, I'll stop on the slides. And I'll move over to Tara. So hopefully all of you have access to Tara. And I'm just going to highlight this particular cell. Notice that this is in blue. That lets me know that that's ready to run. So I can run this code cell. What this particular cell is going to do, here it says, let's copy the data sets from ScHARe, Think-a-Thon's workspace bucket to the cloud environment. So these are the two data sets that I'll be referring to in my code later on. This is a data set that talks about lung cancer data, and this is an iris data set. If any of you have done any coding, you're probably familiar with the stem and petal length of iris data set. So I'll go ahead and run that code.
And
All of that
sorry
is,
for
sure,
so
go
sorry
ahead.
for interrupting you. I just wanted to make sure that everyone can see and access the tutorial before you start. Is that okay?
Yeah,
Yeah,
absolutely.
I don't see the blue, so that I don't know if there's a way to make it blue.
This blue line, or can you see my screen?
Yeah, I don't have it next to my data prep or.
Oh, okay. Yours is not blue. Is it green, perhaps?
There's no color.
There's no color at all. Oh, that's okay. That is interesting, and I'm not exactly sure why. I wouldn't be overly concerned about it because you're either going to run a code cell. Blue means you're able to run that code cell. Green means you would be.
She might not be in playground mode.
Okay, that could be.
Okay.
Green would indicate that you're in edit mode, and so it wouldn't run for you. But those are kind of, once you've seen a couple examples, as we go through this particular script file, you'll notice the difference between edit mode and run mode. But this was in run mode, and so now that code, these data files are in my active memory. My console has let me know that it's copying these files and that they're in my active memory. So that's really nice of Tara. That's actually a feature of Tara that I don't use all the time. When I run this in Colab, you don't get that confirmation. You get a confirmation that uses another tool that lets you view those elements.
So one of the things you want to be sure is that you're in playground mode, and then that you actually click the run button.
Yeah, that fixed it. Yeah.
Okay,
Good.
great.
And the
Okay.
Polly.
Yes. I'm getting so I'm in playground mode. I clicked on that cell of data and I hit run, and it's telling me access denied, exception, does not have storage objects list, access to the Google Cloud Storage bucket. It's giving me a kind of about a 4 or 5 line, what looks like an error code.
I'm not sure
But
how to help you, so maybe.
What I suggest is that I repeat briefly, just, the last steps needed to access the notebook. And then whoever still has issues, I could use a breakout room and just help them directly.
Okay.
Okay.
Okay,
Yes, so what Bruce is putting in the comments is what I'm getting as well.
perfect. So let's do this. Cindy, do you mind if I share my screen briefly?
Oh, go ahead.
Thank you.
I'll stop.
Okay, so one moment. Okay, so can you see my browser?
Yes.
Okay, perfect. So if you all are here, all you have to do at this point is select the right notebook based on the initial of your last name. So I will pick this one for me, for example. So click on it. And then you should see an open button. If you click on open, well, actually an open button or a playground mode next to it. If you see the playground mode, you're good. I mean, you just click on that. If you don't see the playground mode button, you click on open, because when you do, it brings you to that window that I showed before. And I'm sorry that I cannot show it anymore because I already did it, but it brings you to that window, which, let me see, it looks like this. I actually have a screenshot. So it looks something like this. And that's to create the virtual environment. So once you see that, you scroll down to the button, and there is a create button. Don't worry about changing anything. And when you click on create, that's what gives you the ability to see the playground mode button.
Okay.
Okay, so that's what you need to do. So make sure that you are in the right place, meaning you can see all these analyses. So if you see them, you're good, because you just have to click on the right notebook, open it, and then if you see playground mode, click on that. If you don't see it, click on open, and you'll be brought to that window where you can configure your cloud environment, and you have to click on create. And then the playground button will appear, and you just click on playground mode. That's all you need to do.
So that is what I did, and I hit run and I'm still getting the same error. So yeah, I'm
Okay.
also like Daniel, I'm in playground mode and still getting that same error. So
Okay, then I will help you in a breakout room.
So
thank you.
That's easy. Okay, and
having
anybody else too. I mean, if you're still having issues.
when I try to click on the open thing, it gives me a menu of different kinds of charges. $6 per hour or so. So maybe I'm in the wrong place.
Yeah, let me help you with that. There shouldn't be no charges. There shouldn't be any charges. Like the building is on us today, so
Okay.
I'm gonna help you in the breakout room. So I would invite everyone who still has issues to raise your hands, in the Zoom app. And Mark, Kevin, I would ask you to please put us in a breakout room so that I can help everyone. And
Oh,
Cindy,
I just did a refresh and that solved the problem. Somebody suggested in the chat to do a refresh.
Yeah.
I refreshed, it solved the problem.
happens all the time. Yeah.
Okay, sorry about that. Thank you.
No
Yes,
worries.
refresh.
Everyone, please try to refresh the page if that still doesn't help.
I think it doesn't like it if you re-enter the command after, because when it opens it, it automatically copies.
I'm sorry, say that again, please.
I said when you open the Python, the Jupyter Lab notebook, it immediately automatically copies the it runs it runs the code in line 1. So when if you try to hit it again, it gives you an error. I think that's what's wrong.
Okay. I can help you in the breakout room so that Cindy can go on. Okay. So anybody else
right.
need help?
All right, I'll let you move everyone over into a breakout room, and I'll go back to sharing my screen then. Okay, so for those of you staying, I just want to make sure everyone can see my screen okay. Somebody could give me
Yes.
Yes,
okay,
yes.
perfect. Thank you. Okay.
Yes.
So what we're going to do here is create our first variable. So I'm just going to create a variable, which I'm going to label as STR. And you can do this along with me if you'd like, or if you want to wait, I have built-in time where we can do each of these exercises after I demonstrate this. So it's completely up to you. But if you do have some trouble with the code or something, let's wait until we get to the part of completing the exercises to address questions. And this is very
so
short.
mine is
too.
already pre-populated. All of the stuff that you're typing is already there. So I'll just follow along.
That would be great. Yeah, yeah. Either follow along, and some of it should be pre-populated, but I'm not sure that all of it is. But if it is, that's fine. So we'll just go ahead and type in STR, and we're going to set that equal. STR is the name of our variable, and we're just going to set that to be equal to character string, and we'll just make that character string equal hello, ScHARe, learners. All right. And so there's a line of code right there. No big deal, just a line of code. If we wanted to see what that line of code looks like, we can use the print function and just type in STR and then run that line of code. And notice that it prints that message down in our console here. Now you could have more than one line of code in a simple code cell. And this is a code cell. This is what's called a markdown cell. Notice that this says markdown up here. If I click here, notice it says code up here. So that's how I know the difference between a code cell and a markdown cell. Notice that this now has a green line because I'm in edit mode. So I know I'm in edit mode this way. So now I'm going to, for example 2, create another variable just to get a flavor for creating variables. We'll make this variable called X, and we'll set this to the value of 4. And then we'll make a variable Y and set that equal to 2 times 3. And then we'll create a print function for those 2 variables, and we'll say print X and Y. And this time when we run the cell, we'll get 2 messages. We get our hello ScHARe learners, and then we'll also get our 2 variables. It just simply says 4 and 6. Doesn't necessarily describe the values. You would have to provide more data around that to give more descriptive data. And as you learn more advanced coding features, you'll learn how to do things like that. So if we were taking a dance class, and this is our basic code here, and we're learning perhaps the cha-cha, our basic code would be the equivalent of forward step to the right, cha-cha-cha, backward step to the left, cha-cha-cha. But in order to have a beautiful dance, you kind of need to learn more steps, right? You need to learn ladies underarm turn or open break or 5th position to have a more elegant dance. So what we're moving on to here, the tuple, and again, we'll get a chance to try all of these, but with this tuple, it's more of like a ladies underarm turn, if you will, just a little bit of a fancier step. So what I'm going to do here is just type in and create a list, and I'm going to call my list fruits underscore, I'm sorry, I need to back up. I'm going to create a tuple. I inadvertently said list. I'm going to create a tuple. I just can't believe I did that. I smacked my fingers for it. It is a tuple, so it's a fruit tuple. And I'm going to use a double quote. I could use the single quote here. It doesn't matter whether you use a single quote or a double quote, but it does matter that you're consistent in your code. And again, these are things that you would learn as you learn to code. So we'll just put a few fruit names in here. I'm going to put in apples, bananas, cantaloupes. And then we'll put in dates. Notice that I've selected fruits in alphabetical order just to note that tuples require that you use 1 parens and 2 that order matters in a tuple. So now I can simply say print my fruits, my fruit tuple. And then when I run that code cell, it says,
It
notice
seems
it
that
gave,
you're missing an if.
Exactly. Notice it gave me an error message and then I'm missing an S from my print statement. So I just need to add that S in there. And then it will print those fruits there for me in the console area of the screen. I also want to create, actually, I want to create a list before I create a loop. So see this loop here? That actually should be 3.3. This should be 3.2. This should be this loop here. We can adjust that by simply using this down arrow. And now I can put my list over my loop. All right, so let me create a list.
How did you edit that? You just put your cursor in there and...
Right, exactly. So loop was up here above. I highlighted it in edit mode. And then see this arrow here? I just clicked on that and it moved it below list.
Okay, it's just, okay. It's not editing when I try to click
Just
into
double
it.
click.
Yeah.
Double click, got it. Thank you.
Sure. Okay. Now, the other thing is I'm going to take this line of code and I'm going to create a new code cell. Here I have list here. Wait a minute. I'm hitting the escape key. Oh, I highlighted list. It's green. I'm hitting the escape key, so it's blue.
Sorry, how do you add list? I don't see list. I only see loop.
Me too.
Sorry, can't help with that.
How do you add a row? Because I'm missing a row.
Sure. So if you want to add a new cell, just use this plus sign. Okay. And that'll add a code cell for you. All right. Now, for those who don't have list, you can create a new code cell, but maybe you want to change that to a markdown cell. And then you simply can type in pound, and then type in 3.2 and list. And now you've created basically a header as a markdown or
When I
text
added
cell.
When I added the row, it's in
It's in
green.
green.
It isn't in that very same blue. Yeah.
That's okay. Green just means that it's in edit mode.
Okay, got it.
Okay. So now I'm going to delete this one because I don't need this one. So I'm going to come up here and use the scissors and cut that and make that list go away. So here's the list. I wanted to demonstrate that the list can be created again using square brackets. So I have list here as a header. That's my text file. Now I want to create a code cell underneath that. So I'm going to hit escape to make sure it's blue, and then create a new code cell under that. Okay, so now I know that's in code. It's got brackets there. Here, this doesn't have brackets outside. This has brackets outside, so it's expecting some code. Now my line of code that I want to create is actually right here in this text box. So I'm going to simply just highlight that with my cursor and then hit Control-C to copy it. I'm going to pop it up here in this cell and put it there. And so now I can run that cell, and now that's created a fruit list in my memory. Since it's created up there, I don't necessarily need to create it down here. I just know it's in my memory, so I can delete that. Because this is actually creating the list. This is the list. Here's my fruit list. If I wasn't sure whether that's my fruit list, I could say print fruit underscore list. And I can run that cell. And there, I have my list. And the difference between this cell and that cell is, one, this one has raisins. So if you don't like raisins, has nothing to do with a list or a tuple, but this list has raisins. The other difference is I know this is a tuple because it's parens, and order matters in tuples. In lists, order doesn't matter. And it also uses a square bracket. Okay, and again, these are things that you will learn when you take more Python training. Now, what's so powerful about a list? So we've learned how to do a couple of quick steps. Ladies underarm turn is our tuple. Open break is our list, just say. And now we're going to do a loop. So maybe you do a ladies underarm turn, and I'm forgetting the name of the thing where you do a double loop. But anyway, we're going to create a loop with our list. So in this particular loop, let's just go ahead and run this code. And notice that for our first statement in this loop, it says for I in the range of fruit list. So here's our list. In the range, we have 1, 2, 3, 4, 5 loops. For I in the range 0 through 5, so range indicates the number of items the code will iterate through each time. Print the fruit list. So for I in the range of this list, it's going to print each item in the fruit list. And so we have our list: apples, bananas, cantaloupes, dates, and raisins. Then the second statement says for I in the range 0 through 1. And why does that matter? Because in Python counts items in a list beginning with 0. So apples would be equivalent to 0. Bananas would be equivalent to 1. Cantaloupes 2. Dates 3. Raisins 4. So it's printing all of them, 0 through 5, in that range. Here I've said for I in range 0 through 1. So it's just listing items in this range of our list, 0 through 1. It's printing cantaloupes is in position 2. The other thing about Python is it will stop printing at the item just before your last number in a print session like this. So if I were to say print 2 through 5, and then run this very next cell, it's going to iterate through my list one time. It's only going to iterate through this list one time. and then it's going to print the items that are in positions 2, 3, and 4. Okay. Now I know I just threw a lot at you, but what the point is that you can do a lot with very simple things like iterating through a loop. You can make a lot of different things happen, a lot of different logic happen by iterating through a loop.
Cynthia, could you just go back up to when you created the extra cell?
Sure.
And just kind of quickly just go through what you just taught them.
Sure, absolutely.
You don't have to go through all the steps that, like they don't have to do it again. Just kind of reiterate it. There's
review.
Some that
yeah. Sure. So let's start from the top. So we created just a simple string with characters and assigned a character string to a variable called string, and we printed that. And then we took just some numeric values and then also a numeric equation and set those to values, and we printed those. And then we created a tuple. We knew it was a tuple because order matters and there are parens. And then we created it in one line and then we printed it in the next. Then we started talking about the difference between arguments and parameters. We created a list, and what I had to do, the list was actually sitting in this code cell, which can happen. But I wanted to really demonstrate, one, that you can very easily create text cells. So we created this list text cell, and just we set the font. These pound signs really set the heading. That's all that does. You could have a single or you could have a triple, but it really just set the heading there. Then we created a new cell and copied a list in there. And then we printed that list. And then we had our header for loop. And that header just sitting over really two pieces of code, two iterations, if you will. I for the range 1 through 5 will and again, range indicates the number of times the code will iterate through that list. So if I were to say print the range 0 through 5 and print only 2 through 5 and run that code, notice it has looped through the list 5 times and printed these last 3 statements. Last 3 items or arguments within that list for us. Okay, so that's a lot.
So just one thing, is it case sensitive, space sensitive, and punctuation sensitive?
Yes, in the fact that if you created like if I were to type this with a capital S, that would be a very different element than lowercase str. So it is very much case sensitive that way. The other recommendation I would say is make your variables lowercase, because remember classes, we just talked about it briefly in the overview. Classes need to be uppercase. And so as you learn how to write code, you'll learn rules that that you may want to follow to help you find errors and simplify as you read your code. But if you're creating an entire class, which would include functions and arguments and perhaps other variables in it, have all kinds of things, but you would know if you gave that class name an uppercase letter, then you would know it was a class, and it would make your code easier to understand. I had mentioned, yes,
question.
Sure.
Oh, real quick. And so that we have, apples all the way through raisins, but it's 0 to 5. Why isn't it 0 to 4 if there are only 4, okay. I think well, 0 to 5 is actually 6 spaces, right?
It's actually, well, because the list will stop at the character right before it. So let me do this. Let me change that to 4 and run that code again. And notice it stops at raisins. I'm sorry, it stops. Well, it printed 5 times. Actually, here, this is what I wanted to do. Well, it does stop at wait a minute. If I
I just did it and it cut off raisins. It did cut off raisins.
Okay, yeah, 0 to 4 is what I think I'm gonna do here.
Right.
It'll
did 0
loop
to
through
4
the
and-
iteration 5. It'll loop through the iteration 5 times in this sequence, but it will print out. Let me just make this 1 through 4.
Then it would cut off apples, right?
Yeah, see, it stops at raisins because raisins is in position 5. So it stops with date. I'm sorry. 0, 1, 2, 3, 4, 0, 1. Oh, so it's going to print bananas, cantaloupes, and dates. Yep, that's what it printed. Bananas, cantaloupes, and dates because they're in positions 1, 2, and 3. And I listed 4. It stops at the position before whatever number you list there. Okay. So it stops 1 short of whatever position that is.
Got it. So there are 5 items, but we go 0 to capture
the first one,
to make sure we have the first one.
Yeah,
Okay.
and
Interesting.
it's iterating through that list 5 times. Notice it repeats bananas, cantaloupes, and dates 5 times. It loops through 5 times, but it's only printing the arguments that are in positions 1, 2, and 3.
Got it. And for the second print function, in the range of this is the second print function where we have print 1:4. And it's printing out. So it's going through, it's looping through 5 times, and it is only printing what is between not just 1 and 4, but 1, 2, 3, 4.
No.
Is that
so this section here where it says apples, bananas, and raisins, it's going through the list and it's just printing each item once. But this one, it's going through the list 5 times, but it's only printing bananas is in position 1, cantaloupes is in position 2, and dates is in position 3. So it's only
there we go.
Printing those, but it's printing them. It's looping through each time and printing only those 3 each of the 5 times it loops.
So we have to have this kind of logic that we want to go 1 more than the variable. Or are we looking at variables within those, or what's the proper term for what the banana is within those?
The
brackets?
argument, the argument of banana, yeah.
Okay, the argument of banana. So we want to go 1 step beyond our list to make sure that we capture all the arguments in a way. We have to have that in mind.
By default, if we just eliminated this, it would just print the list. It would just print all of it. So if we wanted to narrow the scope of what we're printing, that's a method to do that. And then again, that's really a higher level code, but I just wanted to show you something that's possible.
And loops are just a function of a list. They're there to take a list that you've set up and then be able to manipulate it. Or
Correct.
Is there?
Yeah.
They don't exist on their own. They exist to be a layer on top of a list that you've created. Is that the way to look at it too?
So yeah, you have really 2 kind of main tools, if you will, to help you figure out logic. You can either iterate through a list, or you can use if-then statements.
Got you.
Those are your main logic ways of controlling your logic. So I just kind of wanted to give you a flavor of what that looks like.
Yeah, I don't want to get too deep into more advanced Python coding. I really want Cynthia to go through what she wants to show you today, because this is an overview. This
Sure.
is
Yes.
not learning
Absolutely.
Python.
Yeah,
Thank you so much.
absolutely.
Thank you.
Sure.
And I really want her to get these concepts across to you.
Sure.
Because it's one thing to say a tuple, but when you see it in real, you
Mhm.
get a better understanding. So
Right. So there are some definitions of data types in your code here, so I'll let you explore those on your own. And we'll just kind of keep moving on to if statements. So remember above we had X and Y, and so that is sitting in our memory. And so when we use this if statement, if X is less than Y, print X is less than Y, else print X is not less than Y. So if we run that code, it says, oh, 4 is less than 6. Okay, great. Now, if the value of X would change, and I can go back up here and very easily change that value of X, I'm just going to change it to 12. I'm going to run that code so that 12 is actually in my memory here now. I know 12 is there. And now I can scroll down here and the computer will remember the value that I have for X, and it'll run that new if statement, and it'll say, no, it'll run, there we go. It didn't run the first time. It'll run that 12 is not less than 6. So again, this is just to demonstrate that these are tools of logic. So if we go back to our dance analogy, so not only have we learned the basic step of cha-cha, but we've learned how to do a few fancy steps with that. So just to kind of reiterate our learning, let's take, I have 3:55 my time. So let's take just 5 minutes and kind of, if you haven't already created a variable, go ahead. Remember how I told you to create a new cell, so you can create, use the plus sign and create a code cell and create a variable for yourself, and then print that variable. And then assign different variables to the variables and compare them. And then maybe combine two statements. Say maybe create a variable called statement 1 and say hello, and hello Think-a-Thoners, there you go. And statement 2, are you ready to code? And run that, see how that goes. And then if you're feeling really adventurous, go ahead and create a tuple for yourself and print the first and third values of that tuple. And then the same with the list. And I'll remember that if you're creating a value and you wanted to, you could simply copy a statement and paste it into a new cell. If that makes sense to you and saves you some time. And feel free to answer questions. We'll do this until, let's say 5 after 4. At 5 after 4, we're going to stop and move on to the rest of the code that I have to show you. I'll take a few questions, but at 4:05 my time, we'll stop and move on with the rest of our instruction.
Just one more silly question. Do the lines have to be in a specific order in terms of, can there be spaces between the lines, or are there spaces?
There can be spaces. Yeah, it doesn't.
Okay,
Yeah,
it's indifferent. Okay.
Yeah. Yeah. So if I wanted to say print, you can absolutely, if that helps you with readability. You do have to spell your variables right. You can't mess up typing like I do. You do have to spell your variables and all of your names correctly, but you can absolutely have spaces.
And print is just to test if your code is right, correct?
Yeah, it's really a function that allows you to print that information to your console. Yep.
Okay.
it's a built-in function of Python. Here, if I wanted to print,
Question
Mhm.
on the setting an XY value. So I put X at 10 and then Y at 14 divided by 2 and hit print.
Mhm.
And it gave me 10 and then 7.0. Is that like a default on that, or does that, it doesn't matter. That's a correct result. I did it right?
Yeah, it is a correct percent. So yeah, if you wanted
Yeah,
it in a different format, that would take more coding. Yeah.
Got you. Okay, that's what it is. Okay, thank you.
Mhm.
Feel free, that is, while you're doing this, if you have any questions or getting stumped, just speak up.
Absolutely. We've got five more minutes for you guys to play with this, ask any questions you have. Be
I'm
happy
sorry
to-
if you, sorry to interrupt. I'm sorry if you mentioned this, but did you say if the parentheses and brackets were interchangeable?
No, actually parentheses and brackets matter. So
Okay.
notice that here are parentheses, and it's actually a very important detail to Python, and one of the things that you'll learn as you take more lessons. So print is a function, and then I'm giving it an argument to print. So I've put that in parentheses, but then up here I've asked that you further kind of defined what you want to print. And so that is in brackets. And so those items, they do matter. Yeah. If I had switched them around, I'll get an error message.
Got it. Thank you.
Sure. Those are the fun parts of coding. On the upside, coding no longer requires a key punch machine. All right.
And it's interchangeable using I'm sorry, oh my goodness, I'm forgetting what using the double, the quotes versus
quotes. Sure, single quotes or yes,
Single quotes.
you can use either single quotes or double quotes. I just
Okay.
encourage you to be consistent,
Consistent.
within your code.
Got it.
Yeah,
Thank
but
you.
you can use either.
So would you say that the parentheses are just used when you're writing out the statement, and then the brackets are when you're listing things? Yes, like naming and putting names.
Right. The quotes will kind of define your arguments for you, especially for
Right.
like character strings and that type of thing. Yep.
But for the brackets, you would put brackets when you're like listing things, and then the parentheses around a statement. Or no?
So yes. In this case, this is a list, and so the brackets indicate that it's a list. And actually, technically, fruit list. I have to think about this. I'm going to be careful. So that's calling that particular argument, but because it is an argument of one, I guess technically it could be a tuple. I had never thought about it that way before, but you just, I was like, okay, yeah, technically that's a tuple. So yeah. And then if I only wanted certain characters in that list to run, because fruit list is a list. Fruit list is definitely a list.
I got you. I'm just trying to differentiate in different coding. Usually they aren't different. Like you can interchange them. So I was just trying to differentiate when you do use it. I think I get it.
Mm-hmm.
I think it's really what the intent of the list is for, right?
Yeah.
Some lists, it doesn't matter the order. In a tuple, it does. To learn cha-cha, you have to go 1, 2, cha-cha-cha.
Right, backward. Yeah.
You can't go 1, cha-cha, 2.
Right.
And so
Now everyone's doing the cha-cha. All right. All right. I have 4 after, so we're at a good spot. So what I'd like to do, now that we know how to do a basic cha-cha step and we know some basic moves, when I took my first Python course 2 summers ago, of course, we had to do a group project. And I had a colleague who I actually spent, I'm going to tell you, an entire Saturday trying to figure out what my classmate did very beautifully. And I was like, yes, that's exactly what I wanted to do. And she laid the code out so nicely. And it really demonstrated how you could take a scientific statement and figure out some analysis with it. So I asked her if I could share the code. And her name is Joyce Thomas, and she works for NICHD. But so she created this code, and we're just going to run through it real quick. So first, remember I had talked about the pandas library that allows us to look at data frames, and then NumPy allows us to do some analysis on that data frame, and InterTools also allows us to do additional analysis on that data frame. So we're going to run that first. We're bringing our libraries in, and now we're accessing that data set. You may remember if you go under data, you'll find this data set sitting there. And this is what the data set looks like. This pulls the line of data in. This head function allows us to look at the first 5 rows. And remember, we talked about Python being 0-based. So it's 0, 1, 2, 3, 4, 5 rows. And then we can look across all the fields of this particular data set.
Awesome.
So we'll run and bring that in. Okay, and then we can view that. And then the next thing Joyce did is she wanted to know what data types she was dealing with, because data types matters. It matters what you can do with the code. So she took a look at that. And then she started creating simple counts of what you can do with the data. So she wanted to know, in this data frame, in this list, how many people had lung cancer and how many did not. So that was the first question. So that's how many people have lung cancer. This cell is how many do not. And again, it's just by creating, it's pulling in that entire data set.
Yeah.
And then it's looking at, it's creating a variable, and it's looking at really just the 1 characters. Notice that this means someone has cancer. This means they do not. So that's how she parsed out that data. And then really just using simple logic of 1s and 0s. Notice we have 1s and 0s for lung cancer, gender. We can cluster by age group range, cigarette smokers, and glyphosate users. So
Cynthia, just a minute, let me interrupt a little bit.
Sure.
This is why data dictionaries are so important, because you have to know how they're coding. So
Right.
you could put yes, no, right? So they could have words, or you could put the ones and the zeros. So the way that you get that information is from the data dictionary. So Cynthia, can you go back up to the code?
Mhm.
Yeah, right here.
This code down here. Mhm.
Yeah, right here. So notice that what they're doing is that she's making just in this cell, in this particular one that she has highlighted, these are the ones that have lung cancer. So she put in the codes with the 1 and the 0 because that is the way it's coded on the data sheet or on the data Excel spreadsheet. So that's how she knows whether to put in a 1 or a 0, or if you looked at the other data that she was looking at, sometimes there was a 4 or a 5. So you you pull that information from the data dictionary, from the data sheet. And that's why they're so important to know how they translate, because that's what you have to use when you write this code.
Exactly.
Would you mind showing the data sheet again, please? I never
Sure.
noticed.
Sure. So here's
Okay.
the lung cancer column, and it has 1s and 0s. So
Got it.
what Joyce did is she created one variable called lung cancer positive, and so if an item in the list had a value of 1 in the lung cancer field, then that particular line of code or that particular set went to lung cancer positive. If it was a 0 in that table, then it went to lung cancer negative.
Mhm.
Okay.
Thank you.
Then in her next line of code, she starts parsing out gender, age group, cigarette smokers, and glyphosate users. And again, those were very simple 1s and 0s, and age group had a range. And then same, she was able to, you have the general field of gender, but then males versus females, people younger than 55 years of age, smokers versus non-smokers, and glyphosate users, non-glyphosate users. And so by just setting these simple variables, she's able to start making some analytical statements.
And Cynthia, so can you go back to the data set?
Sure.
So those labels are the ones that are up here on top. And what's really important, and I don't know that we're going to have time to get to all the notebooks that we have on the ScHARe website, but we have a lot of this code. And what's important about this is kind of what Cynthia is showing you right now. So look at the labels at the top of this data set. Cynthia, could you go back to the cell that you were in?
Sure.
And now look, these are the same labels that are getting put into this string. When you have your own data set, if you wanted to run, let's say you want to know the number of people who have diabetes, you could change the green part to take lung cancer out and put diabetes. And then you can just take these, remove these labels and put your own labels in, because the code is all there. It's just a matter of replacing labels. So that is an easy way to start using Python and these notebooks without having to know.
Are all data labeled uniformly like they are in this data set?
So data labels can be whatever you'd like them to be. They can be meaningful for you. But if this code is doing exactly what you need some code to do, but it's using different data, different contexts like diabetes, then you can almost use this like a recipe book. Like for instance, if you're creating a recipe to, I don't know, make a highly saturated fat recipe, but you want to make it that lower fat and sugar recipe, then you just simply follow the same recipe, but you substitute, the healthier ingredients. So code is very much like that.
Yeah, and again, that's why you need a data dictionary. And I keep pointing this out because all of you who are doing research, you have to learn to start doing that. You want to create a data dictionary so that you can take a variable name, and all you have to do, like in this cell, right where Cynthia's at, is you can remove the word gender and put in your variable, which can be address or zip code. It doesn't matter what the labels are. It's just you replace it, put it in quotes, put a parenthesis.
And the zeros and ones you can also assign arbitrarily.
You can, yeah, it's kind of, and we'll see how they're used in if statements in just a second. Let me proceed on through this code, and you'll get an idea of how the logic evolves. So wait a minute, let me go back up here, make sure everything's running. Sometimes code just will not run. Okay, there we go.
And by the way, thank you for everybody who's putting in helpful information in the chat. Thank you for doing that, because we all teach each other.
Oh, terrific. Yeah, I haven't even looked at the chat. Now we get to these if statements. So once we've broken things out, we can start using these if statements. Here's gender, smokers, like phosphate users. So we'll go ahead and run that bit of code. And then once that bit of code is run, here, this line of code imports the visualization library Seaborn and the also visualization library matplotlib, specifically the pyplot. It imports those libraries, and then it allows us to set this visualization. And so this shows us that in these various age groups that were broken down, we have males who have lung cancer and females who have lung cancer. And this line shows who the smokers were, and then by age group and the variation in cancer. And then here's the control group looking at the same data, those who do not have cancer. And my code's just not, there we go, wait a minute. And let me run this last cell. There, now the control group ran as well. Again, males and females by these age group clusters who are cigarette smokers who do not have cancer. So they're very similar in these data sets.
The question was, is this a density plot? It is a data plot.
It's called a violin plot, is the type of visualization. Does that answer the question?
Yeah.
Okay, perfect. All right. So you see quickly how quickly you can do analysis and create an interesting visualization. Let me just run through a couple of quick more visualizations, because to me, visualization is like one of the greatest things about Python. So again, we're pulling in some of our libraries. You don't need to repeat that because it's already in memory in code. I do it here because you can kind of copy and paste easily as a whole set. Here we're using that commonly used iris data set that's being pulled in, and then we're setting the variable to iris. This shows our table. The head shows 0, 1, 2, 3, 4. It's looking at a specific species of the petal width, petal length, and septal length and septal width of this particular data. It sets the IDs to 1, 2, and 3. And then just that easy with having them set to 1, 2, and 3, it allows us to generate this cluster plot. So let me just run these cells quickly, and you should see that cluster plot created on yours as well. If we wanted to move or change this from a scatter plot, is really the term that should have come out of my mouth, not cluster. I just realized I substituted that incorrectly. But if you didn't want to use the scatter plot and preferred to use a box plot, you simply just change the name of the plot. That's really the only difference there. And you can see how quickly you can have a different visualization. And same for a histoplot. Again, you can change that and run that. So I encourage you to explore that. Then I just want to point out a couple of websites. Purdue has a really great website that allows you to play and explore with visualizations. So I'm just going to kind of run this code that I brought in from Purdue. And notice here is another scatter plot using that iris data set. And notice that it changes the data to various colors. So you can quickly do that by changing colors. And I'll point out how you can do that and how you can explore that on your own. Here's a histoplot. Again, really just changing by the name of the plot. You can change the variable. If you wanted to do a pair plot, something fancy like that, you can do that. Here's a pair plot that has different hues by species for that same iris data set. Here's a pair plot where you change the height and the symbols by changing this markers ID. And then here is a map diagonal plot or a map off diagonal plot. And again, all of this I pulled from Purdue's site. Seaborn, also I put the URL for Seaborn there. There are many other plots there. I actually have here's Purdue's sample page. So I encourage you to explore that. I had hoped to kind of infuse these lines through here, but I'll let you play with that because we're kind of running out of time and I don't want to hold you guys over. Also, here's Seaborn's statistical visualization page. That's the URL at the bottom. So just so you get an idea, here's their gallery of all the different visualizations that you could create. I share this as motivation for learning Python, because once you get to learn how to synthesize all of that good data and using those data dictionaries and all of that, then you can really make meaningful visualizations with your code. So that's kind of what I wanted to share with all of you today. I had hoped to do some independent exercises with the data code, but we are kind of running out of time with that. So I think I will take any questions that you have for the remainder of time. And let me see if I have an example histoplot. Here's a.
So just to create these plots, you have to be in the Terra workspace or something similar.
Or something similar. You could be on Google Colab to create them, or
That's
Terra.
the IDP thing that.
So each one will have a different index of how to insert kind of plot you want, or they all kind of have
They use the same Python code. So you could download this notebook and upload it into something like Google Colab if you wanted to. Does that make sense?
Yeah, that does. I just wondered if the index for what is a underscore in some, not in others, is universal for the kind of plots you want.
Yeah, as long as you install the libraries where you install the libraries using that install matplotlib, etc., install Seaborn, then as long as they're installed, then your code should run. Oh, this is a completely different, never mind. I'm just going to confuse people that way. Sorry. I'll stop. I'll stop and answer questions. I won't confuse anybody anymore.
Did you, within this exercise, did you show us how to import different data sets? Was this a single data set we've been using this whole time, or?
Yes, this is, well, so yes and no. We've only been using the iris data set when we were looking at these visualizations. This particular visualization was a data set that we created in our group. And so we imported that in. And so those data files are sitting over in your data tab. But we brought those in. That was the very first thing we did, is we brought in the iris data set and then the lung cancer data set. It's the very first thing.
We would be able to set up a window with, you know, a code window, and then copy and paste and do that. If you wanted to try a different data set.
Yeah, if you were, so if you're playing with this on Terra, you're all set. You don't need to do anything. If you wanted to move it off of Terra, Iris you can get anywhere. If you just Google Iris dataset, you can find that dataset. It's actually built in some Python platforms. The lung cancer dataset, using the one that we used, you would have to download that and then use it, which it was a freely available data set anyway. This is just a subset of something that we found out on the web.
I think the important part to that is that, of course, you have to always download data first.
Mm-hmm.
And then once you download the data, then you can run all of these codes. And this is a good, quick sort of count and visualization of the data. But you do always have to download you have to identify a data set.
Yeah.
So we have a lot of data set in Excel. I mean, so that wouldn't work. We'll have to first kind of convert it to.
So you would have to, right, you would have to set your path to upload that Excel data set. So you would have to download, you would have to create a file, a .csv file with that Excel data set. And then you would have to set your path. So here, on Terra, there's a special way of setting up the data set.
I was going to say, we actually have on our webpage on the NIMHD Think-a-Thon, there is a module, a video recording of how to upload data sets, Excel spreadsheets, and how to download. So, Luca, do you remember what month that is?
I can check.
I can look it up, no worries. So it just automatically converts it into this kind of data set that you have here?
Well, you have to give it a line of code. So here I've set a variable called data JT. Actually, Joyce created this. And then this is pandas, PD. Remember when you say pandas equals PD, this is why you use PD. So you don't have to type out the word pandas every time. And then it'll say PD.read, because you want it to read the CSV file in. You create that, and then you put your path in quotes, and that'll read your data frame into your code. And then you can start analysis on your code.
Yep.
That was September last year.
Okay. So in September of that's listed on our webpage, it'll teach you how to upload data and download data. And there's slides to go along with that as well.
Perfect, thanks.
The one visualization that I thought was kind of fun to learn, let me see if I can get this to run quickly, is this. Here's this iris histoplot. And I thought using the multiple stack feature, just by adding multiple stack to the back of that code, I thought that that generated an interesting plot. And again, it's just showing how really just adding comma, multiple equals stack gives you a little bit more interesting visualization. So I'll just leave that there for everyone as well. I'll put that line in the chat if you guys want to copy that and add that to your line of code. Feel free to do that.
So we are at 4:30. And Cynthia, again, wonderful job. Thank you for helping
Thank
us.
you. Thank you for having me. Yeah.
You go at a pace that even I can follow.
Well, that's good. I think it's a great tool. It does take some time and effort and commitment. It takes time, effort, and personal commitment. But once you have that, if there's something repetitive that you're going to do, it does make your life easier.
We didn't have a chance to get to where we store a lot of this. I think Lucas showed you in an analysis tab, and it was where all the notebooks for this course was, but there's also many other notebooks there that have code, excuse me, have code just like what Cynthia walked you through today. And that code can be cut and paste. All you have to do is, as we explained it, that even with what Cynthia did, is you have to upload your data set. And then when you cut and paste the code, even from hers or from the other notebook, you can actually run these analyses without knowing Python, because they're already there for you. And you just look at the list header of what it's doing. We will have a future session in which we can go through these. We're also next time going through Python libraries, right?
We are. So our focus will be on when you have a data set and you need to clean it, different ways to clean it, different ways to do that. Because as you were saying earlier, that common data element is so important. And then also, I believe we're exploring natural language processing, which is huge for everyone in machine learning.
So, of course, there's the natural language processors, whether it's ChatGPT or Gemini or whatever, are emerging on the scene, and you can actually tell them to produce the code for you. We're not really advocating for that.
Right, right. Yeah, this is more.
We're not advocating for that.
Right. This is more kind of creating your own, like how to do your own. Yeah.
It's not perfected yet.
Right. And that session, it won't be like this session. This is a very easy session. The other ones are going to be more advanced, and I wouldn't expect you to be able to jump right in and tag along and do that thing, but it's to show you what can be done and that it's easy enough to learn those things. But it takes the time and commitment to sitting down and learning them.
So we're going to have a follow-up to this Python piece and sort of giving you some other techniques, advances next month. We will have more series dealing with how to use Terra and where the Python notebooks are, etc. But keep in mind that they're on our Think-a-Thon webpage as well. So you can always go and pull this information up on your own. So I'm really thankful that you guys, so many of you stayed here the whole time learning, and I hope that we see many of you next month as well, as we learn more parts of Python, because this is the language of AI. So we have to learn it, whether it's painful or easy. I'm going to turn it over to Mark now. We ask that you do an evaluation and help us improve our Think-a-Thons. So if you can please take a minute to actually complete the evaluation form. It helps us a lot, so please take the time. We will close the session. Mark will keep the evaluation posted on Slido so that you can finish it, even though we will sign out. I just wanted to remind people, I've put it in the chat, that when you first sign up onto an account, you actually get $300 in free credits. You're only billed when you do analyses and stuff like this that are difficult. The cost for social science types of efforts are minimal. And it's the ones that have horrific costs are usually genomics, who run overnight, and they're looking at terabytes of information or petabytes of information. So $300 lasts a long time for us. And Luca, do you want to add anything to that?
No, it's perfect. Thank you, Debbie. Thank you for reminding everyone.
Just one quick question. Do you prefer Python over R, or do you recommend that for future work? Because there's a lot of people still doing R in our institution.
Yeah.
Python is the language. Go on, Luca.
Oh, no, I was saying that Python is the language used when, there's data manipulation or, AI, machine learning, or you have like large scale data processing. And R excels like like there are many packages like for bioinformatics or biostatistics. So it really depends on, the use. And most researchers, often use both, or, choose based on the specific needs of their projects. But in general, I would recommend Python personally.
Okay.
Epi, what do you think?
The suggested primo language of AI is Python. You can use R.
Just wanted to know, I want to use Python, but we have these R addicts in our institution.
It's hard for people to change what they know, right? Okay, Mark, do you want to bring up the...
Yeah, absolutely. So it should already be live, everyone. We've seen 30-something people have completed the evaluation. If you're still with us and you haven't, please go to slido.com, use code Python, or you can use the QR code on the screen, or click the direct link in the chat. It's the same Slido we've been using all day. Just a few evaluation questions there. We'd love for you to fill those out before you go, and we will keep the Slido poll open this evening. So if you don't have a chance to finish it right now, you could still get it done today, and we really do appreciate your feedback. So please just take a few moments to share it.
We can stay on for a few more minutes if there's any glaring or pending questions. I also put in the chat many links to free Python courses. In case you missed that, we're going to leave it open so you can scroll up and click on any of them that I put in there.
So I see someone asked if Python has a GUI interface like SAS. So really Google Colab and some of the Anaconda services are really, they're not a GUI, but they're a platform that supports writing and using Python code.
Any other questions? Anything we can help you with?
Hi, this is Shop. Sorry.
It's okay.
Hi, this is Shop. I'm actually from Tampa, from University of South Florida. And I actually joined, initial, and then it was new job. So everything just was, I was getting used to it. I'm back, and how do I go to the next level? That was my question. Who do I reach out to? I did get an invite for something this morning, but it was too late and I couldn't join the meeting. So how do I move forward? I mean, disparity is something that I would like to do, and Python and AI is something I work on, so it's not new to me. I am pretty advanced when I look at all this.
I will suggest, can you put your email into the chat? And
Yeah, I can do
Elif, if you can get her email out, and Elif will follow up with you. And we have research teams that are actually working on health disparity topics right now.
Mhm.
And if you would like to join one of them, I'm sure she can get you integrated into it.
That would be great. That would be great, and I'll watch out. I've given my university email. Should I give the Gmail that I'm signed on with Terra, or would this be okay?
You can use any email that gets you into the ScHARe system. Our government emails get us in. They're linked to our Google accounts. So
Right.
not every school does that. So some people have to create a separate Gmail account, but
Mhm.
use whatever works.
Okay. Sounds good.
So if you can, did you put your email in and Elif will get it out?
Let
Or
me put it
can
again.
we can make sure that we get it either way.
Hi, my name is Mary. I wrote in the chat box about using a Yahoo email to sign up for Terra. When I signed up, I haven't really gone into setting up my account. So do I need to change the email I used before I was granted access to a Gmail account?
Luca?
I'm sorry, can you say that again? I was trying to understand.
She used a Yahoo account and she wants to know if she has to use a Gmail.
Yes, you do have to use Gmail. Feel free to email us at any time. We can add you using your Gmail address.
Okay, thank you. Because the one I used was Yahoo. And
did it get you in?
I haven't gone in to sign up yet for the account, but I just got an email that I was that I can register and set up an account, but I haven't done it yet on the Yahoo.
I think you have to use a Gmail account.
Okay. I will send an email to you to let you know so I can switch the Yahoo to Gmail.
Okay, perfect.
Thank you.
Of course.
Anyone else? I hope we give you time to look at the chat and copy down any links that you needed.
I'm adding more. Actually, I'm adding more. That's what I was doing. I'll be ready in a minute. Okay, here are more links for you to more free resources.
And many of these classes are free, so you don't have to worry about cost.
Hi, Luca. Can you hear me? I wanted to ask a question.
Sure.
Okay. Are you guys also going to be offering training in other platforms like Power BI or Tableau or things like that? Or are you planning on offering those kind of courses? I know you're offering Python, but just wanted to ask.
Thank you. No, that's a good question. I think we're going to focus on Terra and ScHARe, right, Debbie?
Yeah.
Okay, thanks.
And, you know, and if you put it into the evaluation or suggestions, then it's something we will consider, because what we're trying to do is get everyone at a place, we're trying to upskill people to do this. So if doing other things is important, then we'll definitely do that. So I hope everybody has a chance. We're almost 15 minutes over. If you have a chance to go through the chat and copy all the links that you need, we appreciate that feedback on the evaluation. And again, our gratitude to Cynthia for helping us. And next month, we will have other parts of Python task that you can get introduced to. All right, and with that, we'll sign off, and thank you all for coming.